In our previous two videos, we talked about ionization energy, and we talked about the trends of ionization energy as you go across the periodic table. The second type of trend that we're going to discuss deals with the size of the atom. Okay, many times when we refer to the size of the atom, they will call it the atomic radius. So we're talking about the size, the radius, as we know, is the distance from the center out to the very last electron. So wherever those valence electrons are. Okay, now this is the reason it's going to be exactly the same as ionization energy. Okay, as you go from left to right across the periodic table, atom size decreases, which means that atoms get smaller. Okay, you would think, well, the protons are going up and so are the electrons. Okay, but if you think about it, the number of protons increases. And again, just like ionization energy, those valence electrons that you're adding as you go across the periodic table are occupying the same shell. They're all in the second shell, or they're all in the third shell, etc. So those are the things that the grader is going to be looking for. What I'm going to be looking for is that as you go across the periodic table, you talk about the attraction to the nucleus increasing because the number of protons increases, or because the nuclear charge increases, and the fact that the valence electrons are all in that same shell. They're occupying the same shell. So a greater number of protons increases the attraction, and because they reside in the same shell, atoms get smaller as you go from left to right. Remember, don't ever say that something is smaller than something else because it's farther to the right on the periodic table. You cannot use that reasoning. You must talk about atomic structure, which means the structure of the atom. Talk about the protons, talk about the electrons. Okay, so example 1, carbon atoms are larger than fluorine atoms, or you could say that backwards. Fluorine atoms are smaller than carbon atoms. Explain using principles of atomic structure. So carbon is not smaller, larger, because fluorine atoms have more protons, so the attraction is greater in fluorine. Okay, so that's part of the answer. And then I would also mention that carbon and fluorine's valence electrons occupy the same shell. Okay, you say that. More protons in fluorine, valence electrons occupy the same shell. You're golden. Anytime you go across the periodic table, that's what's going to be the case. Okay, example number 2. An unknown element, L, is located in the same row of the periodic table as another element, E. And again, they do this on purpose just so you're not looking at the periodic table to find the elements. But L has roughly double the atomic mass of E. What does that tell you? If you're thinking about the periodic table, what does that tell you about the periodic table? If they're in the same row, it means they're both here or here or here. Okay? And if L has double the atomic mass of E, that also means its atomic number is bigger. And if its atomic number is bigger, then again, where is it on the periodic table? Well, if E is here, then L has to be over here. L has to be farther to the right than E. That's what they're trying to get to you there, get at there. Okay? So L has roughly double the atomic mass, which means its atomic number is greater, which means that L has more protons. Okay, so more protons. Is the atomic radius of L less than, equal to, or greater than the atomic radius of E? Justify your answer using principles of atomic structure. Okay, so obviously we can see the answer down here below. Okay, the atomic radius of L is less than. Notice the first thing that I did here is I answered the question. The question is L less than, equal to, or greater? Less than. Answer the question first, then give your explanation. Sometimes as I write the explanation, the answer comes to me. So leave a little space at the beginning if you're not sure what the answer is. But then you can just start saying, well, since both elements are in the same row of the periodic table, their valence electrons are in the same shell, but since L has more protons, it has a greater attraction, And so, oh, that means L has to be smaller. Absolutely, yes. Okay, as you go, and again, remember, this is all just Coulomb's law. Okay, remember that just like with ionization energy, the greater number, and you absolutely can refer to Coulomb's law when you do this. And they might even say, explain using principles of Coulomb's law rather than atomic structure. Okay, as you go down the periodic table, just like ionization energy, the same thing. As you go down the periodic table, of course, the size of the atom gets bigger. Okay, and why? Because you're adding more electron shells. They're farther away from the nucleus. Those valence electrons, in this case, do not occupy the same shell like you do when you go across the periodic table. As you go from fluorine to chlorine to bromine to iodine, you're adding more electron shells. So as you go down the periodic table, the distance between the particles increases as more electron shells are added to the atom. And then that decreases the attraction, and that makes the atom bigger. So here you can see that trend, that as you go across the periodic table, we know that atoms get smaller. Okay, and as you go down the periodic table, here you can see increasing radius. That means atoms get bigger. Okay, and that same trend applies with the exact same reasoning, is that the first ionization energy, IE stands for ionization energy, goes up, and as you go down the periodic table, the first ionization energy goes down. Okay, and the explanation for why this happens is exactly the same reason why this happens. Why do atoms get smaller? Same reason that ionization energy goes up as you go across the periodic table, because the valence electrons occupy the same shell, but the number of protons increase, so the attraction gets greater, making the atom smaller and making it require more energy to remove an electron from the atom. Both reasons right there. Okay, why do atoms get bigger and why does the ionization energy go down? Because there's more electron shells that are farther away from the nucleus, which decreases the attraction, which makes the atom get bigger and makes it require less energy to remove an electron. Okay, bromine atoms are larger than fluorine atoms. Again, look at the periodic table. There's bromine, there's fluorine. Explain using principles of atomic structure. And again, you can be specific like I am here. Bromine's valence electrons are found in the fourth shell, which is much farther away from the nucleus than the valence electrons in fluorine, which are found in the second shell. Okay, that's a good way for you to tell the grader, look, I know electron configuration. I know that bromine has way more electron shells than fluorine does, and by looking at the periodic table, you know that bromine, yep, is in the fourth shell, and fluorine, yep, is in the second shell. So that's a great way to describe it. Okay? Now, atomic radius can also be used to help to explain why the length of one bond is shorter or longer than that of another bond. So this was actually on a recent test. They put that little arrow there and pointed at that bond between the carbon and the oxygen. And then the question was that carbon-oxygen bond indicated by the arrow above is longer than any of all of these carbon-hydrogen bonds in the compound. Explain the reason for this difference using principles of atomic structure. Okay, and the length of the bond has to do, the bond length is just what's the distance between the center of the carbon atom and the center of the oxygen atom. That's all the bond length is. So why is the distance from this carbon to the middle of this oxygen greater than the distance from this carbon to any of the center of the hydrogens? Is simply because an oxygen atom is bigger than a hydrogen atom is. Okay? So, and that's what you would say. You said since oxygen has a larger atomic radius than hydrogen, because, again, why is oxygen bigger than hydrogen? Because it has more electron shells. Oxygen has 2 electron shells. Hydrogen only has 1. Therefore, the distance between their 2 nuclei, or get fancy here, look at that, huh? Their internuclear distance, that's the distance between the nucleus of one atom and the nucleus of another atom, of course is going to be greater for carbon and oxygen than it is for carbon and hydrogen. Okay, and in our next video we will talk about cations and anions.